Hey everyone, welcome to the start of another new topic. In this topic, we are talking mainly about indices and surds. Now, indices we have touched on quite a bit before when we've been talking about the index laws in previous years. So what I'm going to be doing here is we're going to be looking at, in this video, further index laws. So any differences or maybe the similar patterns that we notice when we have different types of index laws being applied. So here we have a product of two numbers, all to some power, and we have the division of two numbers, or fractions to some power. We're going to see what happens when these different types of algebraic expressions occur when we look at indices. And in doing that, we're also going to revise some of the previous index laws we have looked at before. In the practice of doing these questions, we are also going to be revising a little bit. Now, once again, if any of this is unfamiliar to you, please go back and watch those old videos because they go into this in a lot more detail. I'm going to be going a little bit faster here. With these first two questions up the top, we're going to go slowly, observe any patterns, and apply this to some harder questions later. So let's jump straight in. So this first example, we have 2 multiplied by x, or 2x in short, cubed. So cubing a number, as we've learnt many times before, is the same as taking this number and multiplying it by itself 3 times. So you have 2 times 2 times 2. Now, from here, let's just collect both the whole numbers as well as the algebraic terms. So I'm going to break these up because all of these are multiplying in essence, so it doesn't matter what order we write these in. So what I'm going to do is I'm going to group the 2's together first. This is like saying 2 times 2 times 2 multiplied by x times x times x. Now, 2 times 2 times 2, all multiplying together, is the same as getting 2 cubed here, multiplied by x, it's timesing x by x by x. That is like saying x cubed. And now if we wanted to simplify it all the way down, I know what 2 times 2 times 2 is, or 2 cubed is. That gives me 8, and x is a pronumeral, so I leave it as is. But let's actually just look at what happened from here down to here and to this step. Because in essence what's happened is that each term in the bracket here on my product got raised to this power 3. These two steps here were just a short, or just taking this long and slow so you can see how we get there. But in essence what we've done is we've taken first 2 to the power of 3, and then we've multiplied that by x to the power of 3. And that's what allowed us to get to this step over here. We applied the power to each term in the brackets that was multiplying by the other. And eventually, once we have this in index form, if we have any whole numbers, we can simplify to get a final answer. Because 2 cubed, I already know what that is, that's 8. So, let's apply a similar thing to this next question. So, I have x over 3 to the power of 4. So this is like doing x over 3 times x over 3 times x over 3 times x over 3. That's what taking anything to the power of 4, for example, is. This is just multiplying 4 times. And that links up with the power here. We saw the same thing happening in the power of 3 in our previous example. Now, anytime I multiply fractions, I can think of that as multiplying all of the numerators by one another, and then the denominator is going to be each of these terms multiplied together. So what I wind up with is x times x times x times x on the numerator. I can shorten that to x to the power of 4. And the bottom thing I can shorten to 3 to the power of 4. And now you can see a very similar thing happening here, because the power once again got applied to each of my terms in the bracket. It got applied to x. It also got applied to my 4. To my 3. So once I get to here, I can once again simplify 3 to the power of 4. That's like, from what I know with powers, that's like 3 times 3 times 3 times 3, and that is going to equal to 81. So these further index laws, or in the book through which I'm working, is they call this index laws extended. This is taking what we know about regular indices and index notation to simplify any operations, any cubing or going to the power of 4 or anything else in which we have more than one term in the brackets. So here we had, in the first example, 2 multiplied by x. And on the right hand side we had x divided by 3, or x over 3 as a fraction. So everything we know happens the exact same way. And we can say from these 2 initial examples that all I can do as a shortcut, because I don't need to write down all of this anymore, because I have a quicker way to do this, a more efficient way, I can just think of this as the power being applied to each of my terms in the expression in the brackets. Now let's take this further to some more complex questions. Now, this thing here, from what we observed in the last example, that's like taking, so this power of 4 is getting applied to each term in the brackets. So this is like saying now minus 2 to the power of 4. And remember, all of these are multiplying here. So that's like saying minus 2 to the power of 4 times x cubed to the power of 4 times y, to the power of 4. And here I can just simplify this. So minus 2 to the power of 4, you can try writing this out the long way if you like, but I'm going to do it a little bit quicker. Minus 2 times minus 2 times minus 2 times minus 2 is going to give me positive 16. Feel free to double check that. Now here we have the power of a power. So I'm taking x to the power of 3, raising that whole thing to the power of 4. Now if you remember, when we have when we have power of a power rule, what happens to these powers here is they get multiplied together. So that's going to give me 16 multiplied by x to the power of 3 times 4, that gives me 12, multiplied by y to the power of 4. And because these are multiplied, in algebra, if we remember, we can shorten these by we can write this in shorthand by just putting these all next to one another. And this implies a multiplication is happening. It's just a shorthand. So once again, and if you want to do this a long way, you can, but this is the same as taking just the power of each individual term in the brackets. And then we just consult our previous index laws, so these power of a power rules, or just regular squaring or powering like we've done here. For example, negative 2 to the power of 4, we know that because we know how to take powers of whole numbers, and this just y to the power of 4, well, that's just that, y to the power of 4. Okay, next example. Now this is where some people get a little bit lost, because they see this thing out the front and they go, oh, okay, there's a 4, and there's a power here. So let me take that power as well. Well, no, because that power is only applying to the things within the brackets. So the 4, we actually leave this guy on his own over here. So the 4 stays like this, and my 4 is getting multiplied by this power of 5, getting applied to c squared and d cubed. So this is like saying 4 times c squared to the power of 5 multiplied by d cubed to the power of 5. And where we get to now is we know that what happens with these powers is when I look at the power of a power, so I'm timesing here, I'm timesing here. When I have the power of a power, my 2 powers multiply. Now my 4 gets left alone. We don't do anything with the 4 because nothing's being applied to it. It's just getting multiplied by these expressions in the bracket. So my 4 here gets multiplied by c to the power of 5 times 2 gives me 10. And that gets multiplied by d to the power of 3 times 5 gives me 15. And I can shorten this by just saying 4 c to the power of 10 d to the power of 15. And we are doing the exact same thing here, guys. The power 5 is getting applied to each term in my brackets. Now, let's look at the fraction case here, because we looked at products before. Let's look at when we divide. So when you get to questions like this, they start to look really scary and messy. And yes, there's a lot of places you can go wrong, but as long as you're remembering the power gets applied to each particular term in my bracket expression. As long as we remember that, we're okay. Because this 4 is we're doing the power of 4 to each term here. Now this question is a bit of a combination of ideas because we have products and we have a division happening here because of this fraction there. Okay, so let's just take all of these terms and individually take them to the power of 4. So you can see here, yes, it's getting messy, but if I just take my time with these, there's not too much that will go wrong. So here, I took my -2 to the power of 4. I took my a squared to the power of 4. I'm taking my 3 to the power of 4. I'm taking my b to the power of 4. And I'm taking my c cubed to the power of 4 as well. Let's give ourselves some more space here. Okay. Now all I have to do is just find what each of these terms is going to be. So -2 to the power of 4, that's similar to what we encountered before. That gives us 16. And that's multiplied by a squared to the power of 4. So this is once again a product of a product. We've covered this before. So I'm just going to multiply these 2 powers together. So that gives me 16 times a to the power of 8 divided by 3 to the power of 4. We looked at that in the previous example as well. That gives me 81 multiplied by b to the power of 4. And that gets multiplied by c cubed to the power of 4. Once again, I'm going to multiply these 2 powers here, giving me c to the power of 12. And from here, I can just shorten this algebraically. So I just write 16a to the power of 8 over 81 b to the power of 4 c to the power of 12. And from here, we can see there's no more that I can simplify because there is no common common factor that goes into 16 and 81, nor can we simplify anything else here because these are all different pronumerals, implying a different number. So there's nothing more we can do to simplify this. So no matter how scary it gets, we just keep the techniques we know in our back pocket, and now that we're working with more terms here, we are once again just applying the power to all of the terms in my expression. Now, very last example, I'm doing one more thing here. I'm adding the element of two fractions multiplying by each other. So I'm likely going to be using some more index laws that we all learnt together before. But let's take this slowly. Let's work with this first fraction here. I'm going to take all of my terms and I'm going to raise them to the power of 3 because we've learned before that is how we work through these types of questions. So x squared to the power of 3, that gives me x to the power of 6. I'm working a little bit quicker because by now hopefully we're getting used to this a bit more, and that's multiplying by y to the power of 3 to the power of 3. So multiplying those powers gives me y to the power of 9. And c to the power of 3 just gives me c to the power of 3. And now we can work with the next bracket. So all of these terms here are going to get raised to the power of 4. So x to the power of 4 gives me x to the power of 4. I get also c to the power of 4 here. And I get y to the power of 4 here. And now some of you may be thinking, well, how come there's no multiplication happening like we did here? How do we know to do that? Well, we can also think of this x, this c, and this y as being to the power of 1. Because remember, we said, same with this c down here. When we have a number to the power of 1, that is like just having that number there. Any number to the power of 1, so for example, 4 to the power of 1 just equals 4. So the power of a power rule is still actually happening here. Because if you think, taking the power of 4 to each of these powers, we're going to multiply those. So 1 times 4 gives me 4. 1 times 4 gives me 4. 1 times 4 gives me 4. 1 times 3 in this left-hand side gives me 3. So the power of a power rule is still working, but we can just do it a little bit quicker because we know that these are to the power of 1s. So we're raising all of those to 4 anyway, so we can skip that in-between step. But if this helps you think about it, if this helps you understand it a bit more, then by all means do it that way as well. Okay, now it is time to simplify. So we are multiplying fractions here. Now when we multiply fractions, remember, all of the numerators get multiplied, all of the denominators get multiplied. So this is like saying x to the power of 6 times y to the power of 9 times x to the power of 4 times c to the power of 4 over c to the power of 3 times y to the power of 4. And now you can see I have some like indices up the top here. So I can use my index laws to simplify this. I can say, well, x to the power of 6 times x to the power of 4. Remember, when we're multiplying same base indices, we add the powers. Now, I've covered this a lot more in depth before. Please consult those videos if this is new to you. So we get x to the power of 10, and there's nothing more we can do with the y or the c on the numerator. But we notice that we have a c to the power of 3 times y to the power of 4 on the denominator. So we can cancel. We have, for example, with these c's, we have a common factor, top and bottom. So the highest possible number that goes into this guy here and this guy here is c to the power of 3. So I can take my c to the power of 3 here and How many times is that going to c to the power of 4? Well, it goes one time, because c times c times c gives me c cubed. Multiplying another c gives me c to the power of 4. So I have 3 down the bottom, 4 on the top. Then these can simplify out. That's the same as saying, because remember, we're working with fractions here. So this implies a division. So also we can say this is like saying c to the power of 4 divided by c to the power of 3. And when we divide same base indices, we are subtracting the powers. So that gives me c to the power of 4 minus 3 gives me c to the power of 1, or just c. And we can do the same thing with my y's, because I have a common factor top and bottom. Now I can think of this again as going, well, y to the power of 9 divided by y to the power of 4. When we divide same base indices, once again we are subtracting the powers to give me y to the power of 9 minus 4 gives me y to the power of 5. So that cancels with this, and I'm left with 5 up here. Now, if we rub this all out, we are almost there, guys. Bear with me. What do we get left? Okay, we get, haven't rubbed this out properly. We get x to the power of 10 multiplied by y to the power of 5. Now remember, I'm just getting rid of this multiplication sign, because with algebra, writing these next to each other implies a multiplication. And that's getting multiplied by c. And I have nothing left on the denominator. Well, I have 1, but dividing a number by 1 just gives me that number on its own. So my answer to this in the fully simplified form is going to be x to the power of 10, y to the power of 5, c, multiplied by c. So that is how we can extend the index laws we've already learnt towards more trickier questions, like when we have products, or when we have something multiplying in brackets, when we have products, or if we have fractions as well. The same thing happens. The power just gets applied to each term in my brackets, each term in my algebraic expression in the brackets. But thank you so much for joining me today, guys. I'll leave it there, and I will catch you in the next video.